Today we'll be in our last lesson of Chapter 2, which is 2.8, and we'll be talking about distance and midpoint formulas and looking at special formulas with circles. So our objectives will be to find the distance between 2 points, find the midpoint, write the standard form of a circle's equation, give the center and radius of a circle in standard form, and convert the general form of a circle's equation to standard form. Here's the distance formula you're going to need to know. The distance d between the points, we'll have one set of coordinates, we'll call that the first x and the second, or the first x and the first y. And then the second set of coordinates will be our second x and our second y. So that's why we have 1s and 2s, just so we know the difference between our first set of points and our second set of points. And it's d equals the square root of the x's subtracted, then you square that, plus the y subtracted, and you square that. And at the very end, you take the square root. So in summary, the paragraph below just says you find the square of the difference between the x coordinates plus the square of the difference between the y coordinates. And the square root of that sum is going to be the distance between your 2 points. Okay, so let's try applying this. So find the distance between -1, -3, and 2, 3. So we're going to make this our first x. We'll make this our second x. And then this will be our first y. This will be our second y. And it really doesn't matter which one you make your first and your second, as long as the ones are together. So if the x1 is here, you have to make this the y1. And if this is where you put the second x, you have to make that your second y. So I'm going to plot these points, but the goal of this is so that you don't need to plot the points to find this. So if you did not have a coordinate plane, you should be able to find this without that. But I'm going to go ahead and plot the points just to help us understand where this formula comes from. So if we look at our formula here, we took the second x, which was this 2, minus our first x, which was -1. So if you subtract these, you end up with 3, and then we have to square that, and we get 9. Then if we look at our y's, our y2 was the number 3, minus our y1 was -3. So we have minus a negative, which turns into a double positive. So that is 6. 6 squared is 36. Then you'll add those to get 45. Then the square root of that, if you remember simplified radical form, you can split 45 into the square root of 9 times the square root of 5. And you do that because this 9 has a square root of 3. But 5 does not have a square root. So 3 times the square root of 5 ends up giving you 6 and 71/100ths about, so that's why it's the squiggly equal sign. It says round it to 2 decimal places. So that's saying the distance from here to here is 6.71. And I wish I could make a straight line on here. It's kind of difficult. So I'm going to show you where this formula comes from. If you made a triangle, you have a right triangle. So you could use the Pythagorean theorem here. The Pythagorean theorem, if you remember this from past math classes, is a squared plus b squared equals c squared. In this case, c is going to be our distance, or our d, between the 2 points. So let's look at the two sides. We have a side of 3, so we'll call that A. So I could do 3 squared. Then my other side is 1, 2, 3, 4, 5, 6 tall. We'll call that our B. So 3 squared, I'm down to this point. I have 9 plus 6 squared is 36 equals c squared. That gives you 45. Something squared is 45. Take the square root, and we only care about the positive result because we're talking about distance. So square root of 45 is about 6.71. So we just found C, which is this blue side, which is the distance. So it's actually the same as the D. So that is where the formula comes from, but again, our goal is to not have to graph this every time. We should be able to apply this formula without the graph, but I did want to show you where it came from. Okay, now we'll talk about the midpoint formula. So the midpoint is just the middle point. Consider a line segment that has endpoints x1, y1, and x2, y2. The coordinates of the midpoint of that segment, you take the x's added together, divided by 2. So it's like you're finding the average. And then you take the y coordinates added together and divide it by 2. So if I had a line segment, the midpoint should be in the middle. But we're going to specifically be putting this on a graph using coordinates. So we're going to call this our x1 and this our x2. And then we'll make this our y1 and this our y2. Okay, so then we just plug it in. So x1 is 1 plus x2 was 7. That gives you 8. Divided by 2 is where they get the 4. So the average of the x coordinates gives you 4. And then our y1 is 2 plus y2 is negative 3. 2 plus negative 3 is negative 1/2. Divided by 2 gives us negative 1/2. So now let's see where this comes from if we graph it. So my first coordinate was 1, 2. My second coordinate was 7, negative 3. So our goal here is to find the middle of it. And it's difficult because it is a diagonal. So let me see what we got. We got this is the midpoint. So let me find this on the graph. 4, negative 1/2. I'm going to go forward 4, down 1/2. So it's about right there, which does look like the middle of the line segment. Okay, now we're going to talk about circles. So definition of a circle, you've probably been talking about circles ever since you were little. A circle is the set of all points in a plane that are equidistant or equal in distance from a fixed point called the center of the circle. The fixed distance from the circle center to any point on the circle is called the radius. So if I had a circle here, if this is the center, any point I pick to the edge of the circle is going to give me the same radius. And they're always going to be the same number for the radius, no matter where you go from the center. Here's the standard form for the equation of a circle. So we have an x involved, we have an h involved, a y, a k, and an r. So the r is the radius. That one's easy to remember. The h and the k are the ones sometimes people mix up. H is the x coordinate. And then k is the y coordinate. And this is of the center of the circle. Okay, so this one we're just going to be writing the standard form of the equation using our coordinate and our radius that we know. So we said h was for the x coordinate of the center. So this is our h, this is our k, and radius of 10, so this is our r. So now we're just going to plug those values in. So we'd have x minus 0 for h squared plus y minus -6 for k squared equals r is 10 squared. So x minus 0 is just x squared plus, we have a double negative here, so we'd have y plus 6 squared equals 100. And that is where this answer comes from down here. And we are going to stop there because it wanted you to write the standard form. That was our goal. Okay, now we're going to use the standard form of equation to identify what the center and the radius would be. So this time they give you all the numbers and you have to work backwards to figure out what the center is and what the radius is, and then we'll talk about the domain and range as well. So we know that this is our standard form and we know what our normal formula is. So we're going to work our way backwards to find the center. So we want to figure out, this says -2. So that means this would have been a 2 right here. So our first coordinate of the center is 2. Now this is a +4. So the only way to get that would have been to minus a -4, right? So that means the k is a -4 because we had a minus already involved. So if you see a plus sign, you know there was a double negative involved in there, subtracting a negative number. So that is our center is 2, -4. And we know the r squared is 9. So what did we square to get 9? What squared is 9? Well, if you take the square root of 9, you get 3. So the radius would have been 3. Now I'm going to graph this so we can figure out the domain and range of this. So I'm going to go ahead and plot my center at 2, -4. And then my radius is 3. So what I'm going to do is I know the radius has to go out 1, 2, 3. So this is one edge of the circle. Let's just go straight lines. 1, 2, 3 up here. 1, 2, 3 here. 1, 2, 3 here. And I'm going to do my best to draw a circle. It's kind of hard on a tablet. Not too bad. Kind of a circle. So we're going to use that to find our domain and range. So we know the domain is all the possible x values. And the range is all the possible y values. So let's start with the domain. So if we think of our x-axis here, the x-axis, we are going from -1 here, that's where our circle starts, up to +5. And we are landing on those spots, so we're going to use brackets to show that the x's go from -1 to +5. Then the range on the y-axis here, we're going from -1 down to -7. So you start with the lowest number. So you could say we went from -7 up to -1. And we're going to use brackets because those are exact points on the circle. They are not open dots. Okay, let's try another one of those. So now we have x plus 3 squared. So again, to get a positive number here, that means we would have had to subtract a -3. That's the only way we could have gotten that. So the center, the x coordinate is -3. And then -1, those are easy. That just means I had a 1 here because I did y minus that. So 1 is the coordinate of the center. So I'll plot that, -3, 1. And the radius is 4. So what squared is 4? 2 squared would give you 4, right? So the radius would be 2. So let me go ahead and plot the radius from this center point. So the radius would go to here, here. I'm going 2 away from the center. And then I'll draw my circle as best as I can. Now we'll do the domain and range. So the domain is all the x's, range is all the y's. So our domain goes from -5 on the x-axis up to -1 on the x-axis. And the range goes from -1 up to +3. And you should make sure that these numbers should be 4 apart. And sorry, that should be a bracket. Because the radius was 2. So if you had a radius of 2 plus another radius of 2, your distance across the circle should be a 4 going this way and a 4 going that way. Okay, now this is called the general form of the equation of a circle. So this is x squared plus y squared plus capital Dx plus capital EY plus capital F equals 0. D, E, and F all need to be real numbers. So we're going to start by converting this form into standard form so then we can find the center and the radius. So what you're going to want to do is rewrite it so that you can complete the square. So I'm going to try to get my x's rearranged better together. And then I'm going to have my y's. So I have a missing value here that's going to help me complete a square. And then my y squared minus 6y plus something. We're going to figure out a number so we can complete the square, and that's all going to equal, I'm going to move the 23 to the other side, because otherwise that 23 will just throw off our numbers and give us a lot of decimals. Okay, so our goal is to try to figure out these missing blanks. And remember, we're trying to get this form. So we're trying to make two binomials that are perfect squares. And that's going to equal some radius. So we know right now we have a 23 over there, which is not a perfect square, so we're going to see if we can make it one. So let's think of how we could make this a perfect square. So the trick here is to look at this middle number. If I take that middle number, divide it by 2, and square it, I'm going to find my third number. So that would be 2 squared is 4. So let's see why that works. This middle number, if I add 2 here, look what happens. X plus 2 squared. If I FOIL that out, I get x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4, which is what I wanted to try to get. So now if I look at my next one, let's look at this -6. If I take -6 divided by 2 and square it, I get -3 squared, which is 9. So this is going to be a -3 here. You should notice if I did y minus 3 squared, I'm going to get y squared minus 3y minus another 3y plus 9, which is that y squared minus 6y plus 9. And here's what you need to not forget. I added a 4 here and a 9 here. So I did that on the left side of the equal sign. So I have to do it on the right side as well. Add a 4 and add a 9. So 23 plus 4 is 27. Plus 9 gives us 36. So let me rewrite this down here. I'd have x plus 2 squared plus y minus 3 squared equals 36. And now we can use that to find our center and our radius. So to get a positive 2 here, I would have had to minus a negative 2. So that means my h coordinate equals negative 2. To get a 3 here, I would have just had a 3 subtracted for k. So my center is negative 2, 3. And then the radius, 36, what would I square to get that? It would be 6. So negative 2, 3 is the center. Then I have a radius of 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And there would be my circle as best as I can draw it. Okay, final slide here, just looking at another one that's already written out for you. So they started by putting the x's together here, then the y's together. Oops, sorry. And then they added the 1 over to the other side. Okay, then to complete the square, they took this number, 4 divided by 2 squared, and got 4. Then they took this number, negative 4 divided by 2 squared, is also 4. So they added a 4 and a 4 over here. And to factor that, this piece gives you x plus 2 squared. This trinomial gives you y minus 2 squared, and this last portion adds up to a 9. So using our x minus h squared plus y minus k squared equals r squared, the center, this would have had to been minus a negative 2. This would just been minus a positive 2. So that's where they got this center at negative 2, 2. And then the square root of this 9 gives you a 3 for the radius. So they have the radius drawn in red. And that is the end of our circle lesson and the end of our chapter 2 topics.